If I'm seen looking at the side, it's because I'm trying to go along with the script and not get off topic. The solar system and space in general is very massive. It's a known fact by many people, including myself. Much research has been conducted about our solar system, but what if there's more out there? Exoplanets are described as extrasolar planets or planets outside of our solar system. It's in 2017. Using advanced technology and measurements, an outcome of more than 5,000 exoplanets have been discovered, with some of the most recognizable ones being GJ1214b, Kepler-62f, and HD209458b. Two main techniques used to find exoplanets are the transit and radial velocity methods, Carney and NASA 2021. The transit method is a technique used by NASA to find many of these exoplanets. Invented by William J. Young in 1831 with early contributions from Johannes Kepler, it was first detailed for exoplanet detection by Rosenblatt in 1971 and later refined by Borucki and Summers in 1984. Now, the way this technique works is an exoplanet will usually revolve around its star. When it does, it can block some light, and for a brief period of time, that starlight can get dimmer. With that, scientists can measure the brightness of the star that the light has dropped and can infer that there's a planet orbiting that star. It's in 2017. One of the most famous exoplanets, debated brown dwarf due to its high mass, and a personal favorite mass of mine to be discovered using this transit method is the planet J1407b, also known as Super Saturn, which revolves around the star B1400 Centauri, and it's 434 light years away. It's known as Super Saturn due to its humongous rings, like humongous, and its rings are around 100 times larger than the ones Saturn has, so it's really astonishing just picturing such thing in the universe. Now, the radial velocity method works quite differently from the transit method. Instead of observing the star itself and seeing light get dimmer, they observe color. Orbiting planets cause stars to wobble in space, and it changes the color of the light astronomers see when observing a star, Carney and NASA 2021. Invented by Otto Struve in 1952, this method is also known as the Doppler-Wobbler method, and the way it works is very simple. As the star moves back and forth, its light spectrum shows periodic shifts. If the star moves in the direction of the observer, it will appear to be shifted towards blue, and if it's moving away from the observer, it will be shifted towards the red, Carney and NASA 2021. A famous exoplanet to be found using this method is Pegasi 51b, also called Dimidium, and called Hot Jupiter. This planet revolves around its star 51 Pegasi, which is also called Helvetios, and it's approximately 0.08457 AU, which is AU is astronomical unit away from its star. Now, a lot of these studies revealed that there's more outside our solar system that we know about, and scientists are currently, even while we're speaking, discovering more of these exoplanets. A lot of work goes through in order to find a planet and star. It takes time to even confirm if it's an exoplanet, and if it is, it also takes process to even name these planets. It's very simple how they name these planets though. The first part of an exoplanet name is usually the telescope or survey that discovered it. The number is the order in which the star was cataloged by position. The lowercase letter stands for the planet in the order in which the planet was found, Carney and NASA 2021. What came as a surprise to me about exoplanets was the mere fact that if this is what currently was being discovered, imagine more through the years of what else scientists could find out there. Astronauts and scientists have only discovered a mere fraction of space. The percentage is so small, it could be nearly considered 0%. We haven't discovered as much due to the limits we can only explore with the technology we have, which sucks, but not all of us can be winners, so oh well. We just have to push through with what we have. It does affect the results in studies though, because what we have discovered can only be classified as a skewed representation of the diversity of planets rather than a complete picture of them. The sources have found work really well with each other on how finding exoplanets and describing them. They give similar information about the methods and techniques used, giving us an insider of what they look for. Differences between ETSA 2017 and Carney and NASA 2021 is the information given. Don't get me wrong, they explain things similarly, but Carney and NASA go into more depth about the processes such as naming the exoplanets and the telescopes used to find them. Something else as well is the tone, and yes, I know a lot of people will say not necessarily agree that tone shouldn't be a difference, but when it is said from a scientific standpoint, I think it does matter. Edson describes finding exoplanets in a very optimistic way, and he also explains it in a way that it's thrilling just to even discover. And which there's nothing wrong with that, but Carney and NASA really go through with showing struggles and limitations they have from a scientific standpoint of trying to find and identify exoplanets, which I like because it shows even while discovering them is exciting, there's only so much you can do. Now, finding exoplanets matter because it gives us a better understanding of our solar system. Even if it's only a little bit that's been explored, it's better than nothing. Something else that helps us understand is having a hope for potential life outside of Earth and help us to know our place in the solar system. As Edson says, with so many planetary systems out there, it seems like almost anything is possible. 2017. For future research, I think I would enjoy seeing more technological advancements on really getting to explore and really go into depth about the exoplanets astronomers and scientists have discovered. I would also love to see discoveries outside our galaxy if that's possible with our advancements. There's a lot that could be said about exoplanets in all honesty, and more into the future, I'm sure a lot more planets and stars will be discovered, hopefully one being habitable like Earth. But like said before, there's a lot of work being put into what we figured out now, and sooner or later we will be able to find a lot more about our universe.